Hello students, welcome to Sort of Sir's classes. We are solving IIT JAM Statistics 2014's question paper, and the problem that we have in hand is the integral from 0 to 1 x squared to 2x f of xy dy dx. Now let us try to find out the area where the function has to be integrated. Now this is the y equal to x square line, and I'll just use another color. This is the y equal to 2x line, so now from x squared to 2x, as x goes from 0 to 1, x square goes from y goes from x squared to 2x. So at 1, x squared equal to 1, 2x equal to 2. So 1, let 1 be somewhere here. Now this is the area that we are talking about in the problem. What if we want to revert it? My claim is that, alright, before claiming, I would just like to motivate this and try to find out how I got into it. So when x goes from 0 to 1, y goes from x to x square. Now note here, y would go from 0 to 1, and at this particular point from 0 to 1, when y goes from, so this is 1 and this is 2, so when y goes from 0 to 1 here, x goes from 2x to x, I beg your pardon, from y by 2 to root x. So when y goes from 0 to 1, x goes from, as we can see here, this line is y equal to x, y equal to 2x, so x equal to y by 2, so y by 2, 2, and this line is y equal to x square, so x equal to root x, root y. So this is what, however, this is one part, and when y goes from 1 to 2, when y goes from 1 to 2, x starts from the y by 2 line but goes only till 1. X goes from y by 2 to 1. Therefore, one part from this we get integral of 0 to 1, integral of y by 2 to root y, fx comma y dx dy, applying Fubini. From here we get 1 to 2 integral of y by 2 to 1 f of xy dx dy. So adding these two, we should get the original answer, and you can see that A is actually the correct answer here, because A gives us the exact same expression as we have found out here. So I'll just repeat the argument from the graph once. Now here the graph runs till this point, and so this is the portion in light green is the one in which we are integrating. So if we want to revert this, as y goes from 0 to 1, we see x runs from y by 2 to root x, these two, between these two graphs. However, when y goes from 1 to 2, x goes from this red graph to the x equal to 1 line. So it goes from y by 2 to 1. So this is the end of the problem. We'll move on now to the next problem. In which cases the system of equations x1 minus 2x2 plus x3 equal to 3, 2x1 minus 5x2 plus 2x3 equal to 2, and x1 plus 2x2 plus lambda x3 equal to mu have infinite number of solutions. So for this, if we take the matrix 1 minus 2 1, 2 minus 5 2, 1 2, lambda x1 x2 x3 equal to 3 2 mu. So I'll just name these equations. This is 1, this is 2, this is 3. Now what we have to do, some manipulation here. So if we do twice equation 1 and minus equation 2, we get 2x1 minus 2x1, that gets cancelled out, minus 4x1 plus 5x minus 4x2 plus 5x2, that gives us x2, and plus x3 minus 2x3, that gives us 0, is equal to 6 minus 4, that is 2. So we get x2 equal to 2. Therefore x1 minus 4 plus x3 equal to 3, or x1 plus x3 is equal to 7. From third equation, x1 plus lambda x3 is equal to mu minus 4. From these two equations, x1 plus x3 equal to 7 and x1 plus lambda x3 equal to mu minus 4, we subtract them and we get lambda minus 1 x3 equal to mu minus 4 minus 7, which is mu minus 11. Therefore, if lambda minus 1 is not equal to 0 and mu not equal to 0, then x3 has a unique value, and hence x1 also has a unique value, because x1 is just 7 minus x3. Therefore lambda minus 1 has to be equal to 0 and mu minus 11 has to be equal to 0, or lambda equal to 1. Right, so there must be some problem. Yeah, I think I messed up the calculation over here. x2, 2 into 1 minus 2, the equation 2 into 1 minus 2 into equation 1 minus equation 2 actually gives us x2 equal to 4. I'm sorry, because it's 3 times 2 minus 2, which is 6 minus 2, which is 4. And so now from equation 1 we get x1 minus 8 plus x3 equal to 3, or x1 plus x3 equal to 11. This is what we get. And from equation 3 we get x1 plus lambda x3 equal to mu minus 2 times 4, which is 8. So here after subtracting we get lambda minus 1 x3 equal to mu minus 8 minus 11, so that is mu minus 19, and so this would be mu minus 19. So lambda equal to 1 and mu is equal to 19, and so D is our correct answer of this problem. I'm sorry for the mess up. We move on to the next problem. Which of the following differential equations is satisfied by the functions y1x equal to e to the power minus 1 plus root 3x and y2x equal to e to the power minus 2x? Okay, so what is, suppose yx equal to e to the power tx. Now y prime x equal to t to the power tx, y double prime x equal to t square e to the power tx, and y triple prime x equal to t to the power 3 e to the power tx, and so on. So if we take a polynomial f of t such that t naught is a root of f, then yx equal to e to the power t naught x satisfies f. So what we need to do is we need to find the polynomial in R such that minus 1 plus root 3x minus 1 plus root 3 is a root of it. So what we do is we do t plus 1 minus root 3 and t minus 1 minus root 3, sorry, t plus 1 minus root 3 and t plus 1 plus root 3. That gives us t square plus 2t plus 1, which is a plus b, a minus b is a square minus 3. So what we get is t square plus 2t minus 2. Now t square plus t 2t minus 2, e to the power tx would be e to the power minus 1 plus root 3x will satisfy this differential equation, and t minus 2, this will satisfy e to the power minus 2x, t plus 2 rather. So t plus 2 times t square plus 2t minus 2 should be our required polynomial. Let's see, t cube plus 2t square minus 2t plus 2t square plus 4t minus 4 is equal to t cube plus 4t square plus 2t minus 4. So if we have this polynomial, now if we have yx equal to some e to the power tx 3 times y, beg your pardon, y triple prime of x plus 4 y double prime of x plus 2y prime of x minus 4 y of x is equal to t cube plus 4t square plus 2t minus 4 e to the power tx, and since our t's are basically the roots of the polynomials, this will be 0 and we are done. So d3y dx cube plus 4d square y dx square plus 2dy dx minus 4y equal to 0, and D is the correct answer. Thank you. If you have any doubts, please comment on the video and press the like button if you like the video, or you can subscribe our channel to get more such videos. Thank you.